Alright, if you are watching this video, it's because you were absent when we did the 2D forces practice. So I will read the instructions and go over how to do number 1. So the instructions state, solve each for the magnitude of the resultant initial force, then using at least 3 different colors and the head to tail method, draw the vectors. Use a protractor to measure the angle between the hypotenuse and the horizontal vector, then show that sine, cosine, and tangent of the angles equal the ratio of the corresponding side lengths. Show all work and include units. Alright, so you need a pencil to start with and a protractor. For number 1, Angie kicks a ball in the air. The vertical component of the kick force is 7.0 newtons, and the horizontal component of the kick force is 7.0 newtons, and the vertical component is 3.5 newtons. So we're going to scale this so 1 newton is 1 centimeter long. And I'm going to put the protractor down on the smaller inside of the semicircle. This measures centimeters, so I will draw a horizontal vector that is 7 centimeters long. 7 centimeters long, and this represents 7.0 newtons. And then I'm going to put the head of this vector against the tail of the vertical vector. And this vertical vector is 3.5 centimeters long. And this represents 3.5 newtons. And now we draw the resultant vector, which is the hypotenuse of our vector triangle. This ball is being kicked up and to the left, so overall that is the direction of the net force, up and to the left. We need to get the length of this hypotenuse, so to do that, you will do the Pythagorean theorem. The square root of 7 squared plus 3.5 squared. You could do all this in one fell swoop in the calculator, and you get a resultant force of 7.8 newtons. Alright, now we need to measure the angle. So to do this, you are going to put the little hole that's in the middle of the protractor at the bottom. You are going to put this at the vertex of the triangle right here. Put this little hole right here where the hypotenuse and the horizontal vector meet, because I want the angle between those. Notice there's this black line with the protractor, and I can place this black line on the horizontal vector so everything is nice and lined up. There are 2 sides that you can read your angle from, either the 180 degree side and it goes down from 180 degrees, 170, 60, etc., or you can read from the 0 degree line going up. We're going to read from 0 degrees, and I will zoom in so it's easier to see. I'm looking at the angle formed between my horizontal vector and the hypotenuse. Horizontal vector is on the 0 degree line, and I'm going to go up and get the angle where the 7.8 Newton line or the hypotenuse points to. So from 0, 5, 10, 15, 20, it's almost at 25, 26, maybe between 26, 27, a little closer to 26. You can see 25, and then going up to the opposite side, even though it reads between 155, 150, the corresponding is between 25 and 30 degrees. So maybe it's around, let me see, make sure everything's lined up, 20, maybe between 26 and 27 degrees. I'm going to go with 26.5. So this angle, theta, is approximately equal to 26.5 degrees. This is a measurement, and measurements are not perfect. That's why I'm using these squiggly arrows. All right, now we need to show that sine of this angle equals a ratio of the opposite side length over the hypotenuse. We're going to show that cosine of this angle is equal to the adjacent side length over hypotenuse. And then we show that tangent theta is equal to the opposite side length over the adjacent side length. Okay, so we'll start with sine. Sine of 26.5 degrees should approximately equal the length of the opposite side, opposite to the angle, that's 3.5 newtons, divided by the hypotenuse, 7.8. You need a calculator, and your calculator should be in degree mode. Usually they come in radian mode. We're not doing these angles in radians, we're in degrees, so you highlight degree, you hit enter, and then you go second mode again to quit. So sine, you see the sine, cosine, tangent button on the calculator. You're going to click sine of 26.5. That's equal to 0.446. And what I want to make sure is this 0.446 is approximately equal to 3.5 divided by 7.8. So now I'll calculate 3.5 over 7.8. And the answer is 0.4487. I'll round this 8 up to 9, is approximately equal to 0.449. They're very close to each other. Again, it's not perfect because I measured this, I'm measuring this angle, and I'm rounding my hypotenuse. All right, we'll do the same thing now for cosine. Cosine of 26.5 degrees should approximately equal the length of the adjacent side, 7.0, over hypotenuse, 7.8. Plug this in the calculator. Cos 26.5, that's 0.8949. I'll round this 4 up to 5, 0.895. 895 should approximately equal to 7 over 7.8. 0.897, very close to each other. 0.897. And finally, we'll show tangent. Tan, I'll make some space here, tan of 26.5 degrees is approximately equal to opposite, 3.5, over adjacent, 7.0. Tan 26.5 is 0.4985. I'll round this up to 0.499. Round the 8 up to 9. So 0.499 is approximately equal to 3.5 over 7, as you guessed it, 0.5. I can add 2 decimal places there, or a total of 3 decimal places. So these are approximately equal to each other. And again, it's approximate just because we're measuring the angle. Now for the fun part. You have 3 colors again. You'll use a color for the horizontal vector, or the horizontal component of force. In this case, I'm doing in red. This is to cement the head to tail method, getting more practice in. I'll have a color for the vertical component of the force. In this case, I'm going to make my vertical blue. And this is 3.5 newtons. And then finally, I've chosen my third color is green, and this will be for my hypotenuse, 7.8 newtons. So that's all we do. I hope you found this video helpful. Thanks for watching, and study well.